Today's honors geometry lesson is on section 6.2 on the Pythagorean theorem. The objectives are to state and apply the Pythagorean theorem. The Pythagorean theorem states in a right triangle, the square of the hypotenuse is equal to the sum of the square of the legs. Or from previous years, you might remember this as c squared equals a squared plus b squared, where a and b represent the legs of the triangle and c represents the hypotenuse. In the diagram, we are given an isosceles triangle with an altitude drawn from the 90-degree angle down to the hypotenuse. Since this is an isosceles triangle, we now know that each segment that is created from dropping that altitude is going to be 6. We can now use what we know about the Pythagorean theorem to find x, which happens to be the altitude of the triangle. So if we look at the triangle on the right, we can also see that that's a right triangle. We know the hypotenuse is 9, one of the legs is 6, and x is going to represent the other leg. So using c squared equals a squared plus b squared, we can now set up an equation. 9 squared equals 6 squared plus x squared. 9 squared is 81. 6 squared is 36 plus x squared. If we subtract 36 from 81, we have 45. Now equals x squared. Now we don't want x squared, we want to get x by itself, so we are going to square both sides of the equation, which leaves us with root 45 is equal to x. Since 45 has a factor that contains a perfect square, we're going to simplify. So we know that 45 is the same as taking 9 times 5. So if we take root 9 times root 5 and simplify that, we're going to be left with the value of x at 3 root 5. In the next example, we are now given a trapezoid that has two congruent triangles as the legs, and we're going to use what we know about the Pythagorean theorem to find x. In this case, in each of those legs and those triangles, x is going to represent the hypotenuse. So this time we're going to solve for c in our equation. So if we fill in the information that we can conclude from the diagram, okay, so we know that the height or altitude is 8. We also know that the top base is 15 and the bottom base is 21. So if we take 21 minus 15, we're going to be left with 6, which means that each leg on the base for that triangle is going to be 3. Okay. And now we can go ahead and use what we know about Pythagorean theorem to find the hypotenuse of the triangle. So this time we're looking for c squared. Okay, so we have x squared equals 3 squared plus 8 squared. So x squared is going to equal 9 plus 64. 9 plus 64 is 73. So to get x by itself, we are going to square both sides of the equation, which leaves us with x equals root 73. Since 73 does not contain a factor that is a perfect square, we are simplified, so the value of x is equal to root 73. In the third example, we are given a rhombus. We know this is a rhombus because all four sides are congruent. One of the properties of a rhombus states that the diagonals are not only perpendicular, but they also bisect each other. So in this picture, we know that this is root 7 and this is x. What we also know is that all these angles are now 90 degrees. So if we look at one of the triangles here, we can go ahead and find x again by using the Pythagorean theorem. In this case, x is going to represent one of the legs. So if we set up c squared is going to be the hypotenuse. So 5 squared is going to equal root 7 squared plus x squared. So if we start simplifying, 5 squared is 25. Now be careful on this one. So root 7 times root 7 is root 49. Okay, so make sure that we square that, plus x squared. So 25 is equal to, we know that root 49 has a square root of 7. So if we subtract 7 from 25, we have 18 equals x squared. And if we square both sides of the equation, we are left with root 18 is equal to x. Since 18 contains a perfect square, as a factor, we're going to simplify into root 9 times root 2 is equal to x, and the square root of 9 is 3. So the value of x is 3 root 2. We can also use what we know about the Pythagorean theorem to find the length of the diagonal in a box or a 3D figure. So we are going to look for a formula that we can find to find the length of the diagonal of a box given the dimensions of a length, a width, and a height. So if you look here, D is going to represent your diagonal. What I'm going to do is redraw that triangle. So if we take that triangle out here, we can see that we're going to have a 90-degree angle. The diagonal is actually going to represent the hypotenuse of the triangle. If we look at this triangle here, that represents the height. And if you look at this line here, they've called that A. So if we want to find the length of D, we're going to use Pythagorean theorem. So we know that if we take D squared, that's going to equal A squared plus H squared. However, if you look at the diagram, we're only given the length, the width, the height, a value for A, and then the diagonal. So if we try to use the information given, we need to find what A squared actually equals. So for the second time, we're going to redraw our figure, and this is going to represent the base. So right here, so we represent our base. And if you look at A, so A is right here, A is actually the diagonal of the base, which is going to make the hypotenuse of a right triangle. Okay, so looking at our figure, this side here is going to represent our width. So the width is here. And this is going to represent our length. And based on the diagram, the diagonal is represented by A. So if we set up an equation to find A is the hypotenuse. We have A squared is going to equal length squared plus width squared. So now we know that in a cube or in a box, A squared is going to equal the length squared plus the width squared. So now what we can do is we can use what we know about the substitution property, and in the original equation, we can take out A squared and replace it with length squared plus width squared. So to find the diagonal of any box or any cube, you can use the diagonal formula. So A squared now becomes length squared plus width squared plus height squared. So this is the formula to find the diagonal of any box. So let's take a look at an example. A box has a length of 5, a width of 4, and a height of 7. What is the length of the diagonal? So from the previous slide, we know that the diagonal squared is equal to the length squared plus the width squared plus the height squared. So in this example, we know that the length is 5, the width is 4, and the height is 7. So let's go ahead and start simplifying. So 5 squared is 25, 4 squared is 16, and 7 squared is 49. So 25 plus 16 plus 49 is equal to 90. So D squared equals 90. So to find D, we're going to square both sides of the equation, which leaves us with D equals root 90. And as always, we want to make sure we're simplified. We know that 90 has a factor of 9, so that's a perfect square. So we can rewrite this as root 9 times root 10. So if we take the square root of 9, we now know that the diagonal is going to equal 3 root 10. In the next example, we are given that a box has a length of 36, a width of 12, and a diagonal of 39. Now they want us to use the equation to find what is the length of the height of the box. So again, using this equation here, we're going to fill in the information that we have. So we know that the length is, the length is 36. We know that the width is 12. We don't know what the height is, and in this case, they told us that the diagonal actually has a length of 39. So solving our equation, we know 39 squared is 1,521. 36 squared is 1,296. 12 squared is 144 plus h squared. So let's follow our rules for solving equations. So if we add 1,296 plus 144, that will give us 1,440 plus h squared. So if we take 1,521 and subtract 1,440, we're going to be left with 81 equals h squared. And if we square both sides, this is going to give us a nice answer. Since 81 is a perfect square, the square root of 81 is 9. So we know that the height of this box is 9. This is the end of the lesson on Pythagorean theorem. If you have any questions, watch the video for a second time. If you still have questions, write down any clarification questions that you may have and bring them to the next class.